This scheme shows the basic components of the plant. The plant contains two reactors, where the reduction of the pollutants and the nutrients will take place. The reactors are usually placed below the ground, so only manholes can be seen. If concrete tanks are used for the reactors, the surface of the plant might look like this. Cars and trucks may go over the plant, so there is no lost area which would be used up. The test plant I used to explain the processes today looks like this. It is covered by a roof, which makes it easy to do experiments there. On that picture you can also see the different pipes that connect the different components with each other. For the plant in China, of course, those pipes will be buried underground, so they cannot be seen and the environment may look nicer then. So let's go back to the scheme. What you can see is that there is no primary sedimentation tank. This means that no fecal sludge is collected in the system. The fecal sludge, on the other hand, would cause odor and causes problem, because it has to be treated further. In our system, only aerobically stabilized sludge is appearing. This sludge is consisting of microorganisms which are, metaphorically spoken, eating the pollution. Those microorganisms grow inside both reactors. They can survive by taking up, so by eating, the pollutant of the wastewater. They also take up the nutrients like phosphorus or nitrogen, which is also considered to be undesirable in the wastewater. So, those microorganisms are very, very important for the plant. The environment must be nicely for them. Different microorganisms need to have different conditions. Some type of bacteria likes oxygen. Some need an atmosphere where no oxygen is present at all. That is the reason why two different reactors are needed. The reactors offer different atmosphere for different bacteria. This ensures very stable processes and results in a far-reaching wastewater treatment. If the microorganisms are served a proper atmosphere, they form a brownish sludge, which is filling the reactor. This picture also shows the grid, which holds back solid parts. Those solids are smashed into smaller pieces that can then be reduced further by microorganisms. This principle ensures that no solid parts will leave the plants and enter the surface water of the environment. Let's come back to the overview one more time. At the end of the process, we desire to have a perfectly cleaned water. So far, the wastewater is mixed with the sludge of the microorganisms and looks brownish. The goal is to separate the bacteria from the clean water. This can be done by sedimentation. At a certain point, the aeration, which was necessary to inject oxygen into the water and mix it, is switched off. This leads to sedimentation of the microorganisms, so that a clear water zone is built up in the uppermost part of the reactor. After a sufficient sedimentation time, the clear water is then discharged into the receiving water. Due to the uptake of the nutrients and the pollutions, the microorganisms grow. In order to have a stable amount of microorganisms in the system, some excess sludge must be always taken out of it. This sludge is pumped onto a humification reactor, which can be seen on that picture. The water of the sludge trickles through the filter, and only the thick sludge stays on top. This sludge is aerobically stabilized. It has no odor at all and will be sanitized by the sun radiation. The water goes through the filter and flows back into the wastewater treatment plant. After a few weeks, this sludge will be dried completely and can be taken off. It can be used as fertilizer or being disposed as solid waste. So far, I was introducing the most important parts of the plants by some pictures. Now I would like to show you a video that actually explains the whole process once again. In the beginning, there is a pollution, which enters the system by washing, cleaning, or toilet flushing. By pipes, this water is collected and led into the first reactor. You can see the wastewater flowing into the plant. The first reactor contains a high concentration on microorganisms, which can be seen in the brownish sludge. This reactor, the first one, is driven with a very low content of oxygen. So denitrification and phosphorus removal can take place here. Here you can see the brownish wastewater, which is actually the microorganisms that you can see. After having entered the system, the wastewater has to flow through the grid. Here the grid is made out of a tube, which only allows the water to go into it through the slots. Out of this tube, the wastewater is pumped into the second reactor. Here you can see the wastewater entering the second reactor. Also, this reactor contains microorganisms, which you can see by the brownish color of the wastewater. As a difference to the first reactor, this part is driven with quite high oxygen content. So nitrification and carbon removal take place here. After a certain amount of wastewater has been pumped into the second reactor, this process stops. Afterwards, a part of the content of the reactor 2 is recycled into the reactor 1. This is necessary for the wastewater to undergo the different treatment steps several times. You can see the recirculation water is also used to clean the grid in case it is blocked by some solids. As a next step, the first reactor is aerated. This is necessary for some special microorganisms and for mixing of the water. This ensures that the microorganisms are in touch with the water very well, in order to take up nutrients and pollutants as much as possible. After aerating the first reactor for a little bit, this process is stopped as well, and the second reactor is aerated. Here, much more oxygen is given to the water in order to ensure aerobic conditions. After a while, also this process stops. Now the microorganisms have time to settle down. This picture shows how the cylinder, which was just filled with the sludge of the second reactor, looks after a waiting period of 30 minutes. You can see that the sludge is concentrated at the bottom, whereas at the top clear water is left. This water can now be discharged. If too much sludge is in the system, this sludge is pumped onto the humification reactor. Here, a submerged pump is pumping the sludge onto the field. The water trickles through the filter and gets back into the wastewater treatment plant. The sludge stays on top and dries by sun radiation. After a few minutes, it looks like that, and after some weeks, only dry soil-like matter is left over. This then can be taken easily and be disposed. No further sludge treatment will be necessary. The clean water after sedimentation will leave the system. This water is very pure and can be discharged into the environment. Here we take a sample directly out of the discharge, and you can see that the water is very, very pure. COD values below 40 are normal. Ammonium concentration is below the measurable area. Phosphorus is removed biologically and bound to the sludge. There is no disturbance in color in this sample. No odor at all appears. Due to a sampler, taking a sample for analyzing purposes is always possible. Some of the discharged water is held back and can be taken at any time. This ensures a high quality and a controllable process.